Hello everyone, this is Omkar from Department of IT, GRIT. So today we are here to showcase our project which is the Blind Assist, which helps to detect the currency for the blind people. Coming to the abstract, in this project we propose to use computer vision and machine learning algorithms to develop a currency detection system for the visually impaired. The goal of this project is to create a system that can automatically identify the type and denomination of the currency and to help the visually impaired with spoken audio based on its features such as texture, color, and patterns on the banknotes. Additionally, fake currency detection, which is counterfeit detection, is a real problem for both the individuals and businesses. Counterfeiters are constantly trying to find new methods and techniques to produce counterfeit banknotes, which are essentially indistinguishable from real money, at least for the human eye. And for visually impaired people, it feels really unfair. So we would like to add the feature of fake currency detection to this product. So what we propose is to use CNN algorithm, which is very good at classifying images. A dataset containing the pictures of various denominations in various lighting conditions is given to it, and it creates a model. Finally, we are going to use the OpenCV library to process the images for fake currency detection check for feature extraction. So, existing systems. We identified two types of systems. The first one is haptic system. Haptic system uses patterns on the banknotes to identify different denominations by touch. However, they have some drawbacks like limited availability. Every note cannot have a special kind of features to identify by touch. Also, they kind of feel complex. Coming to the second system, it is electronic system. This is where technology comes into place. It includes image processing techniques and different models to train and be used for the detection of the currency. Also, they have limitations like limited accuracy and lack of counterfeit detection. So we have seen our existing systems and we have seen that counterfeit detection has been missing. So what we propose is also to include the counterfeit detection. So our proposal includes first one a camera interface. So camera interface will be used to detect live images. Then image processing algorithm. Once an image is captured, the system uses powerful image processing algorithms to analyze the bill's visual features such as color, shape, pattern, and security features. Then the denomination recognition. Our model will be trained using CNN and the model will be imported to recognize the denomination and speech output. After recognizing the denomination, the system converts the information into clear synthetic speech output. Users can hear denominations real aloud, allowing them to uniquely identify and distinguish between denominations of banknotes. And the finally, counterfeit detection. In addition to currency detection, the proposed system also features counterfeit bill detection. It analyzes bill security features, microprints, watermarks, and other features to identify potentially counterfeit bills and alerts users. So we have designed some UML diagrams so that it will be easy for you guys to understand. The first one is a use case diagram where there is a user and there is an admin. So there are different use cases like dataset collection, model creation and training, scan the currency note, counterfeit recognition, currency denomination detection, and the speech output and also the counterfeit note alerts. Coming to activity diagram, it shows the clear process of what happens. So first, the user scans the note, then image processing, feature extraction, check for counterfeit note, that is a fake note. If it is a counterfeit note, then alert the user about the fake currency. If it is no, then identify the denomination and then inform the user of predicted denomination through voice output. Coming to data flow diagram, it also shows the flow of the diagram. There is a user scans the node, and the image is processed, features are extracted, counterfeit detection, then CNN model, currency prediction, and text to speech conversion. Class diagram. It shows the various classes or modules used by us to develop this project. So the main module is currency detector app, which in turn uses different classes like currency scanner, counterfeit detector, currency identifier, and text to speech modules. Coming to implementation. So what happens is upload currency dataset. So using this module, we'll upload the dataset into the application. Pre-process data. We'll use this module. We'll read all the images and resize them to equal size. Then normalize pixel values and split the entire dataset into train and test, where the application uses 80% for training and 20% for testing. Then run the DCNN algorithm. Above processed 80% images will be input to custom CNN algorithm to train prediction model, and use this model will be applied on test images to calculate prediction accuracy. Then scan the node. Using the camera interface, we'll scan the images live. In feature extraction, using the model, the features are extracted and then the denomination is predicted. This is our interface. I am going to show us our code. So this is our code. We have used the DenseNet architecture of CNN. Here you can see DenseNet architecture. I have run the code. I have to start the Django server, and this shows up. You can see there is a predict button here. When you click on predict, the camera gets turned on. The camera takes around 50 images. As you can see, 50 images are taken, and it says I have a 50 rupee note, and it also says I have a real note. Here you can see the images that the camera has taken. I would like to thank my team, Charupla, Sumit and Mahesh Babu, for the support. They gathered some resources and they helped in the documentation process. And I would also like to thank our Ravikiran sir, our guide, associate professor in GRIT. Thank you.